viewers. It's wonderful having you once again at this class. As you have before us, we are still on the air, okay? And this very question, we are asked to calculate this. The question says an aircraft took off from an airstrip with an average speed of 35 km per hour on a bearing of 0.15 degree, okay, for 2 hours. It then changed course and flew on a bearing of 100 degree with an average speed of 20 km per hour for another 2.5 hours. Find its distance from the starting point to 2 decimal word places, and lastly, the bearing from the word S3 to the nearest word degree. Okay, this very question is from NECO. Okay, last year's NECO question, which is 1825. So how do we go about solving this? The main and most important thing that has to do with bearing is what? The sketching of the diagram. Hope you're all listening. So if you sketch your diagram properly, you don't have no problem. Yes. All your problem is what? More like 90% was solved. If your diagram is properly sketched, all your problem are 90% was solved. The remaining 10% just calculate what you have to calculate the diagram. Okay? So let's go ahead and solve the solution. Now, if you notice in this question, we are not given the distance, we are given it in terms of what? Speed and what? Time. Okay? So let's find an expression for speed and what? Time. Speed is equal to what? Distance over what? Time, right? So we want to make this distance the subject. You can cross multiply this way, okay? By having 1 times distance, okay? 1 times distance equals to what? Speed times what? Time. So by solving our distance will be what? Speed times what? Time. Okay? Now let's start from the first sentence. It said an aircraft took off from an airstrip at an average speed of 34 km per hour on a bearing of what? 0.15 degree for 2 hours. So here now, our distance here will be equal to what? The speed which you have here times what? The time. Okay? So let's calculate the first distance. Let's call this what? D1, which stands for the first distance. Okay? That will be equal to speed times what? Time. And that gives us what? Our speed here is 35 km per hour. So I'm going to have it as 35 km per hour means per what? Hour, right? Then for how long? 2 hours. The time is what? 2 hours. So I'm going to have times what? 2 hours. Okay? Over 1. Now what is common here? R is common. R cancel what? R. So we are left with what? 35 km times 2. And that gives us what? 70 what? Kilometers. Okay, we have gotten the distance for the first route that the aircraft was to from the what? Air what? Speed. Okay? Now let's apply the second what? Distance. When it changes what? Course. Okay? Second distance will not be what? The same speed times what? Time. And what is the speed for the second journey? The speed there is what? 22 km per hour. So that will give us 22 km all over what? Hour times what? The time. What is the time taken here? The time we have there is 2.5 hours, right? Now, if you have 2.5 hours, we can equally change this from mixed number to what? Improper fraction, right? So I'm going to have 2 times 2 is what? 4. 4 plus 1 is what? 5. So it was 5 over what? So I'm going to have times 5 hours over what? 2. Okay? Now, R is common. R cancel what? R, right? So I'm going to have what? 22 km times 5 all over 2, right? Now 2 is common, 2 here 1, 2 in 22 is what? 11. So we are left with what? 11 km times 5. And that gives us total of what? 55 kilometer. Now we are done getting our distances. What's the next step? Now we are going to sketch. This is where your attention will be focused at. Once you get the diagram correct, any other problem is what? Solved. Are we following now? Now, how do we find it? Okay, starting from the first one, I said that on the bearing, this aircraft will come from an airstrip, an average speed of what? 35 km per hour on a bearing of 0.15 degree. This is a 3-figure bearing. Okay, in every bearing that has to do with 3 figure, we always start from the what? From the north. True of us. Okay. Now, if you take it from that aspect now, we are given the bearing at 0.15 degree. So where is it taking off from? It says an aircraft took off from an S. That means from that S3, that is where we are going to draw our 4 cardinal word points. Okay? So this is our what? N what? Stream. Okay? And this S3 will draw our cardinal what? Point. Now let's note here as our north. Here is our what? South, west, and what? East. Okay? Now, we take our 3-figure bearing emanating from the what? North as our what? Starting point. Okay? From the north like this, we move how many degrees? 15 degrees, right? In this direction like this. Okay? So this is how the direction goes. So here is what? 15 degrees. So if here is 15, between the north and east, we have a total angle of 90 degrees, right? So if we take away 15 from 90, what will be left here is what? 75 degrees. Okay? Now, what now happened? We are now told that after it flew on a speed of 35 km per hour for 2 hours, what now happens? We are now told that it then changed what? It changed what? Course. Meaning that as it got to this point, it changed what? Course. Now, what is the distance covered from that speed of 35 km per hour for 2 hours? That gave us what? 70 km, right? So the distance here is what? 70 km. Okay? So this is the distance covered. Then at the end of that point, we are going to draw another cardinal point like this. Okay, indicating our north, south, west, and east. Now, if you observe from this point where the airstrip is and the current position of the aircraft, notice that the relationship between this and what? This line here. Okay, there is what? This is the what? A straight line, and another straight line. So they are both parallel to each other, right? So the angle here is alternate to the angle on this side. So here will be what? 75 what? Degree. And here is the angle here will be what? 15 degree. Are we together? Now, having done that, now we are told that we then change course on a bearing of 100 degrees. So at this very spot now, we will take our bearing starting from the north, covering an angle of what? 100 degrees. Are we together? So from here, I'm going to measure my angle from here. From the north to the east is what? 90 degrees. So we have extra what? 10 degrees to make it what? Total of what? 100 degrees. So we have to extend this in this direction. That means the angle here is what? 90 degrees. While this many angle here is what? 10 degrees, right? Now between the east and the south, we have a total angle of 90. So if you take out 10 from 90, you left with what? 80 what? Degree in between this very place, right? Okay. Now this is the current position of the what? Of the aircraft. Okay, we are going to draw that cardinal point here, like this. Okay, having drawn that, the distance from here to this very place, which it traveled a speed of 22 km per hour for a total distance of what? A total time of 2.5 hours, gave us what? 55 kilometers. So here will be 55 kilometers. Okay. Now, from the question, we are asked to calculate what? Distance from the starting point to 2 decimal. That means this is the starting point where the airstrip is. So this current position where this what? Aircraft what? Is. So what is the distance from here to here? So all we need to do now is to connect this point here to this very what? Point. Okay? So we have this as from here to this very place. Okay? That is our final diagram. So having drawn this now, what are you realize from this? We can sketch this out to have a complete triangle. Okay, you can sketch this as this. Okay, this. Okay, and what? This like this. Okay, total angle here is what? 15 degrees plus what? 80 degrees. That gives us what? 95 what? Degrees. Okay, now we don't know the total angle at this very spot here, and we don't know the total angle here because from this very north to this very line here, okay, from this very north to this very east here, total angle here is 90 degrees. Then from this north to this first line, angle here is what? 15. Then from this first line to this east line here is what? 75. But the angle in between is what we don't know. Okay, so information given to us is that the distance from here is 70 kilometers, while the distance here is what? 55 kilometers. Now let's assign angles using letters arbitrarily. If I take here as my word A, take here as my word B, and here as my word C. These are capital letters denoting angles. Okay? So if capital letters are denoting angles, now what would denote the length of the side is small letter. So here is opposing this side, which is what? Small letter what? B. And that is the distance between here and what? Here, as you can see here. Are you following? Then this capital letter A is opposing this side, which is small letter A, indicating what? 55 kilometer. Then this capital letter C is opposing this side, which is small letter C, equated to what? 70 kilometer. Are we together? Now, having done this now, it will be easier for us to find the value of what? Our B. Okay? Now, in any triangle where you are given two sides and the angle of one angle is given and the other very angle, the opposite side of that angle is not given, it will be easier for us to find that side that is not the side that is not given corresponding to that angle that is what given by applying what we refer to as what? Cosine rule. Okay? By cosine rule, we are meant to understand that B, having our B like this, B squared is equal to A squared plus C squared minus the product of what? AC, right? Then multiply by the cos of what? Angle at what? B here. So we have this as cos what? B. Okay? Now each of the parameters here are what? Given. Each of the parameters here are given. So I'm going to have this as what? B squared equals to what? What is our A? 55. Okay? We have this as 55 squared plus what is our C? Our C is what? 70 was squared, then minus 2 times 55 times what? 70. Then times what? Because of the angle we are going to have as what? 95 degrees. Are we together? Are we together? Yes. 55 squared equals what? What do you have as 55 squared? We are going to take the square of 55, then plus the square of 70, adding everything together and subtracting the difference of this. So I'm going to have this as 55 squared will give us 3,055. Then 70 squared will give us 4,900 minus the product of this 55 times 2 times 70. So I'm going to be having this as 7700. Then times what is the cost of 95? Okay, cos 95, that gives us minus 0.08716. Okay, now we take the sum of this, subtracted from the product of these two numbers. Okay, so we have 3,055 plus the sum of 4,900, that gives us 7,925. Then minus multiplied by minus is the word plus. Okay. Then the product of 7,700 multiplied by 0.08716. So we have that as this, which is plus 671.132. Okay. Taking the sum of this together, this will give us plus 7,925. Okay, we have this as a total of 8,596.132. Okay, now our aim is to find the value of this what? B, not B squared. So our B becomes what? The square root of what you have here, 8,596.132. Okay, which amounts to what? That gives us 92.7153 kilometers. Now, from our question, we are asked to give our answer in what? Find the distance from the starting point to 2 decimal place. Okay? So if you have to approximate to 2 decimal place, approximately to give us 92 plus 0.7 watts. Approximate this by 5 gives us 1 added to this one. That will give us 72 watts kilometer. And that is the final answer was with that. Now, what is the next thing we are asked to do here? We are asked to find the bearing from the word air strip. Now, where is the air word strip? This is the word air strip here. And this is where the word aircraft is, okay? The correct position of the aircraft is what? Here. So we are told to find the bearing of this aircraft from this word air strip. Okay? Now, how do you find the bearing of this aircraft from this air strip? What they ask us to find, what is the angle from this knot, okay, where we have this our knot here, to this very what point here. where the line touches what? The line that connects this our airstrip to our what? Where our what? Aircraft is. So let's find total angles from the north to this very line. So all we need to do is to know the very angle inside this very what spot here. So we need to know the angle at this very spot. Okay? And how do we find the angle at this very spot? We can adopt sine rule or cosine rule, but the easiest formula we can apply here what? Sine rule. Okay? So we are going to apply sine rule. Okay? Using sine rule. Sine rule, I'm going to have what? We are looking for the angle at A. So I'm going to have small letter A all over sine of capital letter A equals to which side and angle is given? Side B and angle B. We have already calculated the value of what? Side B. So we have this as what? B all over sine of capital letter what? B. Okay? Be that as it may, value of our A is what? 55. So we have 55 all over sine of angle A, which is what we are looking for, to be equal to our B. We have that to be what? 92.72 what? Kilometer, right? Then everything all over sine of angle what? 95 degree. Okay? Now from this very point, now our aim is to find the value of this A. Okay? So we are going to multiply this like this. So I'm going to have 92.72 sine what? A equals what? 55 times sine of 95 degree. Okay? Now our aim is to find the value of this. So I'm going to divide both sides by 92.72. So this will give us sine of A equals 55 times sine 95 degree all over what? 92.72. Okay? Now what do you have as this? We have this as what? Let's multiply this out. We have 55 sine 95, okay? Then divided by 92.72. Okay? Everything is giving us 0.59092. Okay? Now, how do we make this A the subject? We want to take the sine inverse of what? Of this to find all of our A. So our A will be equal to the sine inverse of 0.59092, and that gives us what? That gives us 36.22 degree. Now we have to give our answer to the what? To the nearest degree. Mind you, this is not the bearing. Okay? The value we have here now is what? The angle right inside this was very triangle. So the angle inside it was 36.22 what? Degree, right? That means inside here now is what? 36.22 degree. So now the question now says the bearing from the airstrip. So this is where the airstrip is and this is where the aircraft. So what's the bearing of this aircraft from this airstrip? Okay, so from the north down to this very point now. So we can simply say that the bearing of the aircraft from the airstrip equals what? From north to this very first line we have what? 15 what? Degree. Then the immediate angle between this north and east we have what? 36.22 what? Degree. So adding this together, we have 15 plus 36.22. That gives us a total of 51.22 what? Degree. Now we are told to give our answer to the nearest what? Degree, meaning to the nearest whole number. Okay? So nearest degree will give us approximately what? 51 degree. And that is the bearing of the aircraft from the airstrip, and that is our final answer. So we thank you so much for joining us at today's class. We hope to see you in our next video. Thank you.